Hello ladies and gentlemen, we're going to do some scatter plots by hand. You are going to be asked to do this, so please follow along. We're going to draw a scatter plot and do a linear analysis using data just like from the lab. Here are some of the numbers we had from these numbers are made up, but you made 4 solutions, calculated the molarity of each of those 4 solutions, and collected the absorbance using that instrument of those 4 solutions, including an unknown that we're going to do the linear analysis with. Please pause and write these numbers down. I'm going to put these numbers right here for my reference while I draw this scatter plot up here. Now for this purpose, when you draw scatter plots in the XY, the moles per liter, or the molarity, is going to be on the x-axis, and on the y-axis we're going to have the absorbance. I'm just going to abbreviate that ABS right here. Now to hand draw this, you can use graph paper, I'm just doing it on this. To hand draw this, my values go from 0 to 0.099 to 1.704. Pretty much they go from 0 to 2. So I'm setting my boundaries. I'm going to put a point in here for 1 and a point in here for 1.5. If I had graph paper, I'd count this out, but I'm just kind of eyeballing this. I would like it if you had graph paper. My values for molarity, well again, they go down to a very low value, practically 0 molarity. And the highest value is 0.000238. 0.0003 is where I'm going to take my highest value. And then I'm going to just kind of evenly space this up. Again, by eyeball. If you have graph paper, you should be using graph paper. So there's my spacing right there. So now I'm going to line up. My first solution had an absorbance of 1.704, so about right there. And my solution 1 had a molarity of 0.000238. So in between these guys here, about 1/3 to 1/4 of the way, so about right there. So when I line up those two things by eye, I get a data point about right there. And that is my solution 1 data point. Solution 2 has an absorbance of 0.07 for these purposes. So that's about right there. And its concentration is 0.000, just below, just a smidgen below this number right here. So I'm going to put that data point about right there. And that is my solution 2. Solution 3 has an absorbance of 0.0248. So that is about right there. And its concentration is 0.000381. I'm going to put another one on here. Halfway in between these two numbers, so dividing this by 2, is 0.00005. 0.00038 is about right here. Excuse me, 0.248 is about right here. 0.000381 is a little below this mark. So about right there is my solution 3. Solution 4, 0.009 absorbance. So about right there. 0.0000152. So about right there. And there is my solution 4. This plots our data points. I want you to use a ruler. I want you to do your best to connect the dots. I'm going to put your pencil and line your ruler up with the 0, 0, with the origin. And then just try to eyeball a straight line that connects them as much as possible. You see that, like, I didn't go through that line. I didn't go through that data point completely. I just kind of skimmed it. This one I skimmed too. I just tried to eyeball a best fit line. If I had a ruler, right there. So that is our step one, the drawing of this plot here. The linear analysis. Our unknown had a measured absorbance of 0.478. That is a number on our y-axis. We want to know the molarity, which is on the x-axis. Our linear analysis, because these things seem to connect with a straight line, a line, we can analyze this. 0.478. It's just a smidgen under that. For our unknown, I'm going to try to intersect with the line and then go down. It's about right there. So our unknown has a molarity of about 0.12345 moles per liters. You are going to be making this exact same plot using the exact same numbers and taking a screenshot and emailing it to me. Thank you.